So earlier on, I said the only classes of IP addresses that we'll be focusing on is class A, B, and C. And then I said class A ranges from 1 to 127. Class B ranges from 128 to 191. Class C ranges from 192 to 223. Now, and these are all unicast addresses, like I mentioned earlier. Now, if you go back to a class A, and I just go back to the number I chose for the class A, 10.0.0 network. Let's just forget about any other thing and just let's focus on this numbers, 10.0.00 something. Assuming there's a machine 10.0.0.1, 10.2.4.1, 10.3.1.2. If I ask anyone that, hey, do you think that these different IP addresses are in the same network? I think there'll be a little bit of hesitation because you're not too sure whether they're in the same network. But there's a concept called subnet mask. It is some kind of a system or some kind of description that help you to see or help you to identify a network, or even helps you to know whether or not two IP addresses fall within the same network. And it can also tell you the size of a network. So what do I mean? Just before we go into the very specifics. So for a class A, the subnet mask is 255.0.0.0. For a class B, the subnet mask is 255.255.0.0. So C will be 255.255.255.0. So someone will be asking, okay, so George, you're saying from your description of what a subnet mask is, you said it helps us to see the size of the network. Fine. You're also saying that it helps, it is more like the measurement for a network. And you also said earlier that it helps you to identify, identify which part of an IP address is the network part. And it also helps you to determine whether or not two IP addresses fall within the same network. And so this is what I mean. If I pick a number like 10.4.2.1 and I pick another number 10.0.0.1 and I ask a question, do you think these two numbers are in the same network? It also means that you need to start thinking about the subnet mask. It means that what is the subnet mask? So basically, how do you know the subnet mask? You need to look at the first number. This is a class A. And so if it's a class A, 10.4.2.1 is a class A because of the first number. So it means the subnet mask for this class A is 255.0.0.0. Forget about the fact that these two numbers are the same. And let's just focus on the fact that we have two different numbers. Now, this is also a second number. And the first number is also 10. It also falls within the class A range. So it means that the second number, which is 10.0.0.1 also has a subnet mask of 255.0.0.0. Now, if I'm saying that the subnet mask helps you to identify whether or not two numbers are in the same network, for class A, we're saying that if you want to know whether, or if you want to know the network part of an IP address, you just look at the first number. The reason why we're saying that is because of the subnet mask. So when you see 255, it means this is the network. So anytime you see 255, it means this part is for a network. So this is 255, it means this part is for a network. So clearly, if you look at the network parts, they are all the same. So this part is 0, 0, 0. So the network part is 10 for here, 10 for here. And the rest is saying 0. Anytime you see 0, it means you just leave it as 0. Anytime you see 0, you leave it as 0. Anytime you see 0, you leave it as 0. So for this first IP address, the network address is this. The second one, this is 255, means keep this. This is 0, it means make it 0. This is 0, it means make it 0. This is 0, it means make it 0. This is the network address. So we can clearly see that these two numbers are the same. And so we can say that 10.4.2.1 and 10.0.0.1 are in the same network because they have the same subnet mask.